Hey, welcome. Have you ever stared down a problem that was so huge, so tangled up, you had absolutely no idea where to even begin? Well, if you have, you're in the right place. Today, we are breaking down a really powerful framework for cutting through the chaos of what we call complexity, uncertainty, risk, and ambiguity. Let's get right into it.
So first things first, let's set the stage. In school, problems are usually pretty neat, right? They're tidy, they have one right answer. But the real world? Nope. It is messy. The challenges you face in your career are almost never well-defined. They're more like these tangled webs of different variables, conflicting goals, and of course, a ton of missing information.
Okay, picture this. You are put in charge of designing a brand new transportation system for a massive city. I mean, where to even start? This isn't just about laying some track or buying some buses. It is a monumentally complicated challenge with what feels like a million moving parts.
And this is what that messiness actually looks like. You're trying to juggle what the government wants versus what the citizens need. You're trying to guess how many people will live there in 20 years. You're connecting huge separate systems that all have to work together perfectly. And all of that is happening while costs are spiraling and political pressures are just building and building. It's a total perfect storm of challenges, and a simple checklist just isn't going to cut it.
So, to make sense of all this, here is our roadmap for today. We'll start by defining the challenge. Then I'll introduce you to something called the KIIT framework. We'll break down each of its parts, and then we'll see how it works in a real-world scenario.
So how do we bring some order to all that chaos? Well, we use a mental model, basically a structured way to think about the problem. And that's exactly where the KIIT framework comes in.
Look, the whole point here is to go from feeling completely overwhelmed to feeling like you're in control. A good framework doesn't just help you take a problem apart, it actually gives you a clear path forward, a place to start solving it.
And here it is, KIIT. It's an acronym and it stands for complexity, uncertainty, risk, and ambiguity. Now, you can think of each of these words as describing a different flavor of messy. And honestly, just learning to tell them apart is the most important first step toward getting a handle on them.
All right, let's start by digging into the first half of the framework. We're going to kick things off with the C, and that stands for complexity.
So what do we actually mean by complexity? It's not just about a problem being hard. A truly complex problem is one with tons of interconnected parts. And here's the critical piece. A small change in one little element can create these unexpected, cascading ripple effects across the entire system.
You can usually spot a complex problem by these telltale signs. There are countless variables all tangled up and depending on each other. Small actions can lead to massive, unpredictable results. That's what we call nonlinear cause and effect. And you can just forget about finding one single perfect solution. You're usually looking for the best possible trade-off among many options.
So how do you manage it? Well, we use something called systems thinking to map out all those interconnections. We use models and simulations to test our ideas in a safe, digital space. We break the giant problem down into smaller, more manageable pieces. That's decomposition. And we bring in experts from all different fields. The whole game is about making that invisible web of connections visible. Okay, on to the U. Uncertainty. Now, it is absolutely crucial to understand this is not the same as complexity. Complexity is about the tangled structure of the problem itself. Uncertainty is all about what we don't know. It's that gap in our knowledge.
And there are two main types of uncertainty you'll run into. The first is aleatory uncertainty. Think of this as pure built-in randomness that we just can't get rid of, like the roll of a die or whether it's going to rain next Tuesday. The other type is epistemic uncertainty, and that's a knowledge problem. We could actually reduce this type of uncertainty if we just had more data, better measurements, or more powerful models.
So we've talked about the structure of the problem with complexity and the gaps in our knowledge with uncertainty. Now let's talk about the consequences. And this brings us to the second half of our framework, risk and ambiguity.
You know, risk is where uncertainty gets real. It's where it grows teeth. It's the possibility of a bad outcome. And we can actually quantify it with a really simple but powerful formula. Risk equals the probability of something happening multiplied by the consequence if it does. This is a great reminder that even a super low probability event can be a massive risk if the consequences are catastrophic.
And because we can put a number on risk, we can manage it systematically. It's usually a four-step process. First, you identify everything that could possibly go wrong. Then, you assess each of those risks using that probability times consequence formula. Next, you figure out how to mitigate it.
What can you do to lower the chance of it happening, or lessen the damage if it does? And finally, you monitor it. You keep your eye on it constantly.
And that brings us to the final letter in KIIT, A for ambiguity. This one is all about clarity and meaning. Ambiguity is what happens when a goal or a requirement or even a single word can be interpreted in a bunch of different ways. It's when your team isn't on the same page because the page itself is blurry.
So where does all this blurriness come from? Well, a lot of the time, it starts with a really poorly defined problem statement. Or maybe you've got different stakeholders who all want completely opposite things. Sometimes, it's as simple as people from different teams using the exact same word to mean two totally different things.
So the antidote to ambiguity is clarity. Simple as that. That means you need rock-solid communication and crystal-clear documentation. It means getting all the key players in a room early and often to agree on the goals. And it means using prototypes, because actually showing someone a working model is one of the fastest ways to clear up any misunderstanding.
Okay, we've broken down all the theory. Now let's see how this entire KIIT framework actually applies to a really cutting-edge, real-world example, designing a smart factory for what people are calling Industry 4.0.
So let's run this smart factory through our KIIT filter. The complexity is just off the charts. You're trying to integrate IoT sensors, AI, robotics, cloud computing, everything. That creates huge uncertainty because we don't really know how all this brand new tech will perform at a massive scale. This, in turn, leads to enormous risks, like cybersecurity attacks or the whole system going down costing millions. And this is all wrapped in ambiguity, because different teams might not even agree on what a smart factory is supposed to do. See how each element kind of feeds into the next?
And this really brings us right back to our core idea. Being able to look at a problem through these four distinct lenses: complexity, uncertainty, risk, and ambiguity. It's not just a nice-to-have skill anymore. For any kind of modern problem solver, it is absolutely fundamental.
And here's probably the most important takeaway of all. KIIT isn't just for engineers. It's a mental model for making better decisions in pretty much any field. I mean, whether you're launching a business, making a policy decision, or even just a big personal life choice. Separating a problem into these four parts is the first step toward actually finding a smart solution.
And so that leaves us with one final thought. Think about one of the biggest challenges on the planet right now: climate change. It is profoundly complex, it's filled with uncertainty, it's loaded with risk, and it is absolutely dripping with ambiguity. If you were put in charge of tackling it, using the KIIT framework we've just talked about, where would you even start?